Hello and welcome to another video. And if you've seen my previous tutorial series, I was showing you how to connect a Pi and Pico with BLE, then connect a Pi with an ESP32. This time I'll show you how to connect to a Pico and ESP32 using BLE. I will show you how to set things up, the errors I made which I eventually resolved, the code, and then I will show you a quick demo. This video will be accompanied by a Medium article which I'll link in the description along with the GitHub repository. Let's get started. First, here's the wiring diagram. So this is very simple and requires no extra components. Now on the Pico side here, all you need is just to get MicroPython installed and that's it. You don't need any extra libraries. On the ESP32, make sure you have the same setup as we did last time. And in case you don't, just make sure to install MicroPython, and then you'll have to install the AIO BLE library. You can use Thonny here, or you can just install it manually using the MicroPython libs directory on GitHub. I'll link the instructions in the description. You'll find it on the Medium article. So let's set this aside and let's get to the code first. First, let's talk about the Pico code, then the ESP32. So here we have the code name Pico Central Dual. We have the libraries. We have the built-in LED. We have connected equals false. Then we have our with statement where we're going to open a JSON file. Here we have our JSON file with the UUIDs for service and characteristic. Now I did have one that had write, but it turns out it didn't work. So one of the main issues I had was when I tried to add a different characteristic such as write, it wouldn't work. It kept throwing away writes until I realized that the way BLE works on the Pico is actually different than what the Raspberry Pi uses, because the Raspberry Pi uses Bleak, which is the full BLE library. Unlike the Pico, which uses a smaller, I would say more a subset of BLE, but basically it can't work with multiple characteristics. So I had to stick with only one, which is just a characteristic here, as you can see. So going back here, yes, we had to open and then read the file. We have the variables here. The most important variables that matter here are the service and characteristics. So what I did was access the JSON file and just looked for service and characteristic. Then what I did here, have message count is 0, encode and decode are still the same. Our blink task is still the same, nothing's changed from there. Our receive data task is roughly the same. The only difference is I do print, and then I do message count, and then I do the sleep for 1 second. I have my timeout error, exception. Then I have send data task, where I send data. If there's no connection or characteristic, it'll just print an error. Then we have our message. Then we write to the characteristic. We have the exception. We have our BLE scan. So what it will do is it'll use AIO BLE scan, and we'll have the usual variables here. And then we will scan. And of course I print results just to see if I can find it, just to see what the results are. Now if the result is essentially I am sending to, which is up here, which is peripheral. So if it's able to find the name peripheral and the service UUID, then it will connect to it, otherwise it'll return none. Then we have our central mode function where we await the BLE scan. If there's nothing, or if there is none, it'll continue. Otherwise it will print the device name. It will try to connect to it, then give a timeout error, and then it will connect using the service and our characteristics. I have connected equals true for the LED, and then our timeout error, and then exception. Then we have our tasks. Yes, I make sure you add all the tasks here, otherwise it won't work. Then we have our disconnected, and we have connected equals false because of the LED. And then we run central mode because everything is contained here. So that's it for the Pico code. For the ESP code, it's pretty much the same. We imported libraries. We also opened the same JSON file. In fact, I'll even show it to you. This one's slightly different because it's actually the same, but the code is slightly different in that because I actually got to get rid of the right, because it turns out I can't add another one. I can only have a single characteristic that can write and read to it. And as you can see here, where it says read characteristic, I have read true, write true, and notify true, as well as capture true. I had to add that instead. Then we have to register our services. Encode and decode are still the same. This is still the same for the LED task. So we send data just like last time. I'm setting the temperature of the ESP32. Then I receive data. It just says receive from central. This means that it was done right. And then of course we run peripheral mode as usual. You don't need this printing statement, but I added it just in case. Then we advertise with the interval, the name, services, and then we connect. We have our tasks. We have the usual gather tasks. Then we disconnect. And then we have our canceled error, our exceptions, and then we run it for every 100 milliseconds. And then we make sure to run peripheral mode as well. So that's it for the code. Now we're going to run a very short demo. So let's get to the demo right away. Hey guys, so the demo is working. As you can see, we're reading back the values. So it's not like last time where we had two different characteristics. Here, we're sending the data from the ESP32 to the Pico, and the Pico is simply reading the values back, and the ESP32 is reading the values back that it was sent. So it's like a circle of sending data and receiving data, and that's pretty cool. So it's nice to see it still works. So that was it for this short demo. So thank you. Thank you for watching. Next time we'll add a potentiometer, as we have done before, to read its values, and then add an LED for brightness control. So thank you for watching, and I'll see you next time.